Hi everyone. So today we'll be discussing about unified observability using Istio and Skywalking. So a bit of a history lesson on why we got to this. So a few of our customers or clients, they came along to us and they're already using Skywalking or they're already using Istio. And whichever way we came from, we wanted to give them a simple sort of onboarding process. So we came up with this topic. My name is Pulakumar Das from IMESH, and let us get started. So moving on to the next slide. So in this video, we'll be talking about the following things. So I'll give us a status quo. So what Istio is, how to implement it and all that. We'll come to that as well. We'll look at what unified observability looks like with microservices. We'll talk about integration with Istio and Skywalking. And there will be a short demo. So I will not be able to go through the entire Skywalking setup process because Skywalking is quite fast compared to the other sort of setups that we have for observability. So if you've already worked with Grafana or any other metrics, telemetry, and traces and log stack, you might see that Skywalking has a lot of things in it. So we'll set up some bits of it, and maybe we'll cover the later ones in a different webinar or a video. And finally, we'll just go over some of the benefits. So first of all, let's look at a sample multi-cloud application. This is a banking application. So as you can see, the user enters through an ingress controller or a gateway. And through this, they hit the profile endpoint, and this profile endpoint will start communicating with the recommendations engine as well as the account summary, like the service. And anytime they make a transaction, it will go to the transaction service. And keep in mind that this is being done over 3 different clusters. So one cluster is holding all of this. There is the recommendation one is being held at a completely different cluster. And we also have a passive transaction service held here. So in case this active one fails, this one can come in and take its place, right? So some sort of load balancing is taking place. Moving on to the next slide. Now we'll be talking about how we are implementing this with the service mesh. So taking the Istio as an example, the sidecar that is deployed here is Envoy. So each and every one of this is being implemented with an Istio, like a Istio proxy sidecar. So these connections are not happening directly. Now they're going through. So every time a connection is coming to the ingress controller and it wants to talk to the profile, now it will go through to the Envoy gateway on the ingress controller side, and then it will go through to the like the Envoy proxy on the profile side, and then it will go to the profile service, right? And the same sort of thing is followed here. There are also Istio gateways to control the traffic between the various clusters here. And most of this is kind of simple. You do not have to make a lot of changes. You can just install Istio, and with a couple of labels or even if you manually inject the sidecar ports, that will also work out. So how exactly do we get to unified observability using Istio? So first of all, let's say that you have a DevOps or SRE team, and they want to observe the setup that is working. Yeah, is everything working fine or not? What's the latency? If any bugs come through, where is the bug happening, and all that. So without Istio, without any sort of observability setup, what will happen is you have all of these microservices talking to each other. Now let's say the recommendations engine failed, right? Now you have to go to the particular service. You have to look at the logs there. You have to figure out if the logs are actually enabled for that application. You'll actually get some logs out of it, and then you'll have to decide like, okay, this thing is failing over here. But you may not know that, okay, so for example, like for a very particular group of users, it is failing or something like that. So that's where these 4 things come into picture. So first of all, we have logs. So for every traffic coming through, we will have some sort of logs coming in. We will be able to view all of them from a single place. Secondly, we have metrics. So each and every one of your components will be giving up some sort of metrics. So what is the latency, the CPU usage, memory usage, every sort of things will be available to us. Next up, we have traces. So anytime a request comes through, we will not be tracing each and every request, but at least for every, say, let's say 100 or 200 requests, we might want 1 or 2. So it's like a small percentage of the requests will be completely saved and captured for future reference. So anytime something fails, for example, we can see precisely that, okay, this request is coming in through like this, and here it is failing right here. So it will be easier to debug that way. And finally, we also need a topology. So the entire application, how does it look? How does it set up? Where all the data is flowing, and so on and so forth. So first of all, we'll be talking about Skywalking to observe all of this. Now, we have also created previous videos about using Grafana or Prometheus to view all of this. The issue there is Skywalking can do a lot more than whatever these other tools do, because the other tools, they only concern themselves with the application level stuff. Skywalking can look at all sorts of things. So we'll start. So for this video, for example, when I do the demo, we will only concern ourselves with the Envoy proxies. So all the Envoy proxies will be sending some data to Skywalking, and you will see how just by sending some of this, you'll be able to get some metrics, you'll get some sort of logs, and you'll also get the topology, right? So just with Istio, just with Skywalking, you're able to get at least three out of four. Next up, we will introduce OpenTelemetry to the setup. So with OpenTelemetry, we will start looking into what the control plane is like, how it is behaving. So every time we do a new deployment, something got restarted, the control plane must send out a request to all of the Envoy proxies and sync their data to each other. So we'll get those metrics. Aside from this, we will also configure OpenTelemetry to talk with the Skywalking endpoint and get its metric back to OpenTelemetry. So we'll be able to observe our own observability setup. That is referred to as self-observability. Next up, we will also be able to get information from the cluster level. So from AWS or GCP or wherever you have set it up, we'll be able to see what is the memory usage and all that. Now, one thing to note here, we have shown that we are fetching data from the Istio gateway. So Skywalking out of the box will support the Apache API 6 gateway and the AWS gateways. Note that this simply means that in the UI, there will be a simple already set of dashboard for you. But for Istio gateway, it will not be there. It will show up in a separate dashboard. So everything is possible. It just takes some time to set it up. So let's get started with the demo. In this one, again, as I mentioned, I will not be able to cover the entirety of Skywalking. So we'll talk about how to set up the access log service of Envoy and the metrics service of Envoy to send data to Skywalking. And we'll be able to get metrics, logs, and topology in Skywalking itself. And then we will also set up OpenTelemetry. So we'll get from Istio, from Kubernetes, and Skywalking. We'll get the data from there. So let me get started. Let me increase the size here. Okay, I hope this is visible. So I think I will go with first deploying some of this because it will take some time. So to get data from Kubernetes, we already have CR Wizard that is integrated into Kubelet. We don't need to worry about that, but we may need to add the kube state metrics. So for that, we first add a repo in Helm. So we'll add the Prometheus community repo. And this is the link. Paste it from over here. Okay, so you do this and you'd hit enter. I have already added that, so I don't need to do this. Next, you would usually run Helm repo update to make sure that everything has been updated. So you can fetch the latest charts. Okay, it's all set up. Now we will be installing kube state metrics, which was in the repository that we added before. So let us take that. So we'll do Helm install and we'll name the Helm chart as kube state metrics. We want to install it in the kube system namespace. And the chart in question is in Prometheus community. So this is what we named the repository before. And the chart name itself is kube state metrics. And while this is installing, we can also start the, okay, just finished. So everything is done. Now we can also start up the, here actually, we can also set up the Skywalking itself. So we'll install Skywalking, and for Skywalking, the official way to get it is through the Helm chart here. So this is the link that you will need to use. And for that, we will be giving the configuration. I'll be explaining what all of this configuration does in just a moment. Let me just get this started. And one thing to note, I already have a namespace setup. So if I do kubectl Skywalking, you can see one namespace has already been set up for our observability needs. There is no Istio injection enabled here. So we'll just install this in the Skywalking namespace. And this is going to take a bit of time. So let me scroll this down. And first of all, we'll be looking at the Skywalking setup. So the official Skywalking Helm chart that we installed here, this one, so it already comes with a bunch of extra things that we can enable or disable as we like. So first of all, we are creating the OAP's like the observability analysis platform. That is the backend of Skywalking, and there is also a UI. So this is the backend itself. So this is the configuration for the backend. And if you scroll down, this is the UI configuration. So we are creating a service account for the backend. And one thing to note, we are using version 9.2.0. So there will be slight changes in the configuration here and there between version to version. We have decided on 9.2 because it was quite stable and it worked really well. This thing will come into picture shortly. I'll explain this. So I've kept it highlighted. A lot of this is out of the box. In fact, most of the comments are from the Skywalking team themselves. I have not added anything here. Most of the configuration that we will do is at the environment variable sides. So this I'll talk about. Similarly, if you come down to the UI section, we are selecting the same 9.2.0 version. I have not configured any of this. Same for OAP init. So this is the init container that is used. No, again, not something to worry about. And okay, coming here. So while OAP is the observability analysis platform is the backend of the Skywalking itself, it also needs to store the data somewhere. So three different DBs are supported out of the box. There are actually multiple more. You can even use H2 as a DB if you want to. But so usually a lot of people seem to use Elasticsearch with it. But for this demo, I have enabled the Postgres for it. So if you set this value to true, it will deploy a sample Postgres deployment into your cluster. Otherwise, you can set the configuration here for whichever Postgres instance you have. Next up, I have also made it create a username called OAP with this password and this database to be created. The rest of it is the standard stuff from the default values.yaml that the team provides, and the satellite configuration. So for load balancing reasons, this is used as a step between the OAP and whatever metrics that you're sending to it. Again, we don't need it for this demo, so I've kept it to false. So none of this matters. Now coming back here. So the main configuration in the Skywalking side of things. So there is, you can divide it into two pieces like this. So this four are setting up the Envoy metric related service. So when it comes to the access logs that we'll be sending from Envoy through the Istio configuration, those metrics will be analyzed in two different ways. Plus, they will be also saved to the DB, so we'll be able to view the logs. So this much works without any like OpenTelemetry. But all of this is set up for OpenTelemetry itself. So what we're doing here, we are creating an OpenTelemetry receiver here. We are setting up a couple of rules that are provided out of the box. So we're saying that whatever OpenTelemetry related data comes to you, that will be related to the Istio control plane, that will be related to the Kubernetes cluster, node, and service level stuff, as well as the OAP's own telemetry. And for the OAP's own telemetry, we are setting up this number of environment variables. So we're saying that whatever telemetry we want from OAP, that will be in this Prometheus format. We are giving it the host 0.0, so it will listen to all of the interfaces on its own. We are giving the port as 1234, and this port matters up there. And this, we are simply disabling the SSL. So this port is also highlighted here in the list of ports. And keep this matrix name in mind because it will come into picture when we are setting up the telemetry character. Okay, so now that Skywalking is set up, we should also set up Istio-CTL, or Istio rather, sorry. So for Istio, I have provided an Istio operator. You can also set all of this without the Istio operator if you want to. I do not have Istio in my like path variable because I tend to use a lot of different versions. Let me install it. So first we'll do operator init. And while that is going on, let me explain what's going on here. So in the mesh configuration, so this is the default configuration that all of our Envoy proxies will receive. We are setting the access log service to be enabled. We are setting the address for the access log service. So all of the access logs will be sent to this particular address, which is what our Helm chart will be setting up Skywalking in. Let me also apply this so we can do install that set. And another thing that I'm setting up is the metric service. So with the metric service, same thing as before, I'm setting it up to go to the Skywalking gRPC endpoint, which is 11800. And with this, I'm saying that you send all of your data to it. So once that is set up, I think I can also set up OpenTelemetry. So let me put this down again. Okay, coming to OpenTelemetry. So the service map is simply setting up a service account. It's simply setting up a service account for OpenTelemetry to use. It needs access to all the nodes, the endpoints, the pods, the deployments, and so on. So it is simply creating a service account. It is creating a cluster role for all of this, and then the cluster role binding as well. Note that in the cluster role binding, I am setting the namespace as Skywalking. If you want to use a different namespace, make sure to change it here. And this will get used in the OpenTelemetry collector itself. So the collector has multiple parts again. At the bottom is the deployment for the collector itself. We are not really doing a lot here. In fact, some of these ports are not needed. Same for the service. But coming up here, the main thing is the config map. So in the config map, we have a couple of things. Let me zoom out slightly. Okay, so we have a set of receivers, we have exporters, and then we have service pipelines. So the way OpenTelemetry Collector works, you set up some receivers, you set up some like exporters, and then you create a pipeline. You can also have processors in the middle. So if you want to batch them or you want to limit the memory usage, you can do that here as well. For this simple setup, we are not dealing with any of that. So for this receiver, we are only configuring one receiver, which is Prometheus. So this will act as if it was like Prometheus, and it can go out and scrape the Prometheus compatible endpoints. Now, a couple of things to note. We have 4 different script configs. So the first one is OpenTelemetry will go out and scrape the Istio itself. That is done through this. So we're looking for the Istio one, and here we are simply replacing the cluster name with whatever cluster name we want to give. So this is something I have entered. You can enter whatever you want. It does not have to be your actual cluster name. Second, so the same thing is repeated over and over. Now coming to the next one, we have the Kubernetes C advisor again. Again, as I mentioned, in the newer versions of Kubernetes, the C advisor is actually part of the kubelet itself. So if you're running Kubernetes already, you should already have this working. So we do not have to do any other setup for it other than setting up this script config. So it will pull data from there. It will give you the various node related information and all that. Next up, we had insert cube state metrics, so that will give us access to the rest of the cluster information. So this is the like the script config for that. After that, the final script config is to create Skywalking itself. And here, one thing to note, we are taking the pod container name and the port name. So we're specifically saying that for the container OAP, look for the port name as metrics, which was defined back in values.yaml. So this particular port will be used. Again, this particular port is set up as here, right? So now that we have Istio installed as well, so we should be seeing some sort of data flowing already because we do not have any applications yet. So let me set up the let me set up the OpenTelemetry collector itself. So we'll do ctl apply telemetry. First, let us do the service account, and we'll do it in the Skywalking namespace. Next, we'll take the other configuration, so the collector itself, then telemetry collector, same in the Skywalking namespace. And I think we should be ready to start looking at the Skywalking dashboard. So Skywalking got deployed in the Skywalking namespace. So let's look at the services. Okay. And then we can port forward it. We'll take this thing in Skywalking, and we will port forward it to 8080, and we want to port 80. Okay, now that this is set up, let me go back to the browser. We'll go to localhost 8080. It might take some time. Skywalking is a bit heavy, so it will take some time to get set up. But yeah, we are seeing the data. Now, dashboard. Now keep in mind, each and every one of these tabs, each and every one of these pages, you need some sort of configuration. We are not concerned with the general service one because this one requires the setup from the agent side of things. So we're not installing the agent into each of our applications. What we're concerned is the service mesh. So if you come down to the service mesh, we will not be receiving any service mesh data here because this particular dashboard is taken from the Envoy access log. We can come down to the control plane. We should be seeing control plane related metrics. So you can see there is no pilot process yet. We'll deploy Bookinfo, the sample Istio1, and we'll get some data there. I think there's some error with the networking. That will not affect us really. Coming to down to the data plane, again, we have got a list of services and all that. So wherever the Envoy metric or the Envoy proxy has been deployed, we are getting that. And this was what I'm missing, right? So if you look at the gateway, we'll get the gateway here. We'll not get it on the side here. So here's the ingress gateway. We can see all the traffic and such flowing through it. Right? We're seeing the memory usage, the number of connections and all that. Coming down to the self-observability, so whatever Skywalking itself is using, that will be here in the first section. The second one, as I mentioned, we are not using the satellite. So here's the self-observability data. So I can not much of a data coming through right now. Going down to the Kubernetes side of things, we have services. So this is being sent to us via the kube state metrics. So this is all the service level metrics. We can even come down to the pods. Okay, this one does not have anything. Same for the cluster. So for the cluster one, we have all the general data for the clusters. We can see all the deployments, the whatever is not running. We can even come down to the node level data. So there are 3 nodes in this cluster, and each and every one of them. Now there's a lot more stuff that you can do. So for example, you can come into the Linux one, and if you have set it up properly, you can even see the Linux level data. So again, not really set up here. Coming back to the services, we need to get some data plugin for this. So I can show the Envoy one. So let me show you the Envoy access logs. So first of all, we need to see that almost this is up. So info should have created one with Istio injection enabled. Yeah, so it has already been set up. Next, I can simply apply the sample YAML file. So it is in software samples Bookinfo platform. Bookinfo dot I think it is group. Yeah, Bookinfo.yaml. And we want this in the Bookinfo namespace. And now that this has been created, if we create a new terminal and we do kubectl get pods, Bookinfo, and we watch it, you can see Istio injection has successfully been set up, and some of them are still getting injected. So coming back to the UI, we should see a spike in the Istio control plane, unless the data has not come through yet. Let me try refreshing. Yeah, so we started seeing some pilot process here. But the main thing to watch here is when we start giving it some data. So we'll put forward the service. One service will be created for product list, this one. We'll do put forward. Let's see. So that's okay. Copy the entire thing. This is in Bookinfo. Port number, I think it's the port number. Check that. Okay, it's all in 9080. So we can take this old one and we can say import 8081, put forward port 9080. Coming back to the UI again. We will not be seeing any data here yet because the access logs are not generated. So let's go into our application. Now do note that I am not using the ingress gateway itself. So we will see some broken data because I'm just directly put forward in the application. We'll just refresh this a couple of times. So we managed to hit all of the different review service. I think there's a network issue somewhere. Yeah, so broken pipe. Let me close this, start it again. Back to the UI. Another one, refresh again. Okay, I think that should be enough. So if we just hit refresh here, we should see some data flow in already. Great. So we're seeing that. So if you come over to the topology tab, again, we're not sending any trace data here, but you will see some topology graphs over here. Generate all the data first. I think we came in too quickly. But yeah, so all of these metrics and all this is simply sent from the Envoy access log service. So if you come over to the logs here, you will see the actual access logs itself. So every time a request is coming into this review service, it is generating this sort of logs at the not at the application level, but at the like service side of things. Let's see if the topology is up. Okay, the topology has not been created yet. Okay, it was actually zoomed in quite a bit. So it's the topology is over here. I think we should be able to see it from here as well. I'm not sure where I've zoomed in. Yeah, so let me show it from there only. Not sure what's going on here. So yes, you can see. So from the product page, two requests are coming in, one to reviews, one to details, and the reviews are sending a request to ratings. And again, you can get but a lot further with this. So you can set up, if you set up Skywalking Rover, you will be able to profile the services here only. If you're using any sort of AWS Lambda or any sort of function as a service platform, you can set it up here as well. Kubernetes, we have covered that. Linux, for this you need to set up the like the Prometheus exporter or the node level browser one and the general service one. So this one is more interesting. So for the services, you need to use Skywalking agent. So for each and every one of your applications, you would need to install some sort of library or something. You do not have to do a lot of changes in your code. Install some sort of library. In some cases, like I think Java, you can also deploy it as a sidecar. And those agents will get more data out of your application than whatever you have shown so far. But again, that's a more complex setup. We are not going there today. Another thing that those agents can do, so if you're connecting to any sort of database, if the agent support it, they will also get the data from there and it will show you that, okay, this is the latency between my application and the database. And one of the interesting agents is the browser one. So for your JavaScript apps, you can put the Skywalking client.js agent and you'll be able to get some data from the user side of things from here. Same for the database side. So we have not set up the MySQL or rather the Postgres one here. If you set it up in OpenTelemetry, we should be able to see some data here. Self-observability, I had gone through it. So this is the observability analysis platform itself. Satellite we're not setting up, and coming here to the dashboards list. So all of these dashboards are set up here. You can actually customize all of them. You can create new dashboards. So let me just show a simple thing. So you can come over here, click this one, and you can go in here and add any sort of widget or topology graph you want to add. Right. So let's move back to the slides now, because that's it for this demo. We will consider doing a better, like a more comprehensive guide to all of the other stuff that we have not covered today. But this was the simple sort of setup for today. Hope everyone learned something from it. So what sort of benefits do you get out of this? I'd say the major one is that because all of this is open source, so whatever I've showed you today, everything from the Skywalking to Istio to the cube state metrics to OpenTelemetry, all of that is open source. So you will be saving, let's say, around 2 or 3 million worth of cost savings. There is nothing proprietary running here. Next, because as I showed you, with Skywalking, if you set it up completely, you will be able to solve incidents much easier. And finally, you will be able to get visibility across all of your services. So database, services, traffic, network infrastructure, even Linux infrastructure, everything. Okay, so that's it for this video. Thank you very much. Let me know if there's any questions that we can handle. Otherwise, reach out to us at contact@imesh.ai.